Hi, everyone, and thank you for joining us at another edition of the Composites Corner by Norplex-Micarta. Today, I'm really happy to have with me Deanna Rothman, and my name's Dustin Davis, and we're going to be talking with you today about standards for composite materials. I'd like to start by asking Deanna to introduce herself, and then we'll get into our topic for today.
All right, hello guys. I'm Deanna Rothman. I'm the QA and ME manager here at Norplex-Micarta in Postville, Iowa, and I've been with the company for 14 years now.
Awesome. So I'm sure we have some people joining us live, and I encourage you at any point in time to enter your questions into the chat box. We'll be taking a look at those and want to make this as interactive today as possible. But as we get started here, I'd like to introduce just a little bit about Norplex-Micarta. At Norplex-Micarta, we are committed to working collaboratively throughout the value chain in order to help companies achieve creative solutions to both their business and technical challenges. We do this from two locations, the one that Deanna mentioned there in Northeast Iowa, as well as one that's about 2 hours west of Shanghai. On a global basis, we have approximately 250 employees and produce over 300 different standard products, many of which are supplied to some of these industrial standards we're going to talk about today. But it's really important to note that we're not just a material supplier. We want to be your development partner and bring around the services that we have around applications engineering, material development, and of course, the all-important ability to characterize the materials and provide ongoing value to design customers. So enough on the background. Let's jump into the topic for today. So Deanna, when I asked you about this, I came to you and I said, I often hear a lot of people talk about in the industry, well, the reason composites aren't more widely used is because there isn't a standard. An engineer can't go to a reference book and find the information that they need. In fact, ACMA has been working and got legislation through the Senate to get funding from NIST to fund a project in standards for composites. And so I thought it'd be really great to have you on and ask you a little bit about giving some insight about the standards that you work with on a daily basis.
Right. So Norplex-Micarta has dozens of materials in sheet, tube, and even rod form that are sold to various standards. These standards set up a minimum performance requirement for the materials and give some basic requirements for the construction or formulation.
Wow. Okay. So despite common myth, I will put it now in the myth bucket, these standards exist and they're well understood.
Yes, they are. Absolutely. These standards were developed over the years to meet the needs of electrical equipment manufacturers. And it's important to note that the environment these materials see in electrical devices may be different than other applications. I also want to emphasize that under these standards, manufacturers will self-certify to them.
Okay, so I think it's interesting and two follow-on questions to that. So for electrical equipment, so you talked about the environment. So in my mind, that means, look, we don't expect rain inside of an electrical enclosure. We don't expect extreme high temperature nor extreme cold. So there's a bit of control around where these materials were thought about. As they were setting the standards, they had a very kind of specific place where they would be used. Now, the other one was self-certify. So let me make sure I unpack that. Literally, a manufacturer could buy a copy of the standard, test it, not test it, whatever, and they get to say themselves that the materials meet. It's that simple?
Essentially, yes. The bigger issue here, though, is there is no control of the product at the formulation level from supplier to supplier. And I've experienced in cases where a customer switched from our material to a competitor's, both meeting the same standard, but the other material didn't work in their unique use.
Okay, so typically that's happened, again, maybe outside of an electrical device?
Correct.
Okay, so it's been a mechanical issue. Maybe somebody put it in a high pressure steam environment or cryogenic maybe. All right, so they kind of took it out of its niche. The materials would work, but there's some formulation differences that matter. So that's really interesting to me, right? Because while the standards you said give some idea, so they may say like the resin chemistry and the reinforcement, why hasn't there been has there been a push to control it at that level?
So yes, there has been. In a unique case where the material was being used outside of an electrical application, there was a push to create what is called a process standard. In reality, what happens here is an OEM or an end user will start with a standard material. and then work with us to apply specific parameters on the materials for use in their application. For instance, they may need a specific glass style, or there may be something we can do on the chemistry side that will enhance the performance of the material.
Yeah, it makes total sense. You know, I can imagine when you're going through a design process, it's hard to get an entire industry to agree exactly on what that formulation should be. So it sure sounds like there's a whole lot of information here. You are clearly an awesome resource. But if I was an engineer and I wanted to do some homework, where can I go to begin that process?
So we've got a lot on our website. Let me share my screen here and get you to our website. And there we are. So here's the Norplex-Micarta website. And I'm going to show you where you can find these standards. So we're going to go to Electrical Applications, Industry Standards. And then you can scroll down here where we've got a list of the standards we were talking about today. We've got NEMA, which is the National Electrical Manufacturers Association. We've got IEC here, that is the International Electrotechnical Commission. This is based out of the EU and is still very active. We've got ASTM for the ASTM D709, and this is for laminated thermosetting materials. And then we've got military specifications. This one specifically the MIL I 24768 that covers thermosetting plastic laminated insulation materials for mechanical and electrical military applications.
Great. So each one of these standards organizations or bodies has a group of either manufacturers, I guess mainly driven by manufacturers, who form a committee and then set minimum performance requirements for both mechanical and electrical properties. Is that right?
That's correct.
Okay. And you said IEC is quite active. For some of these other ones, I assume that a few of the standards haven't been updated in a while. Is that true?
That is true.
Okay. So let's go into one of these. I don't care which one you pick. Either the mill or
yeah. Let's pick
IEC.
Yeah.
Great.
So here we'll go through here. What we notice here is, first thing is, it's kind of split up into the forms of materials you can purchase, which is sheets, round rolled tubes and rods, and then molded tubes and rods.
So Deanna, real quick, all those numbers are different. So when I come in and I ask about a specification, do I just say I want an IEC glass epoxy? Or do I have to say, no, I need IEC 60893-1? Or how does that work?
So if you come to us, you can just tell us IEC, and then depending on the form you want, we can kind of lump it into these buckets.
Okay.
But along with the IEC call out, what would help is if you come to us with a grade type. So here we've got the grade type and the description here, and then of course the Norplex grades that we certify to those grade types. What's nice about IEC is that they've got a pretty intuitive grade type. So we've got here, the first one is EPGC201. So EP is the resin system, which is epoxy in this case. And then GC would be the substrate type, which is glass cloth. So that's really nice here. That helps us kind of all of a sudden lump it into categories. And then the numbers at the end are just descriptions that are more in depth in the standard. You can see here EPGC 202 would be the flame retardant version of an epoxy glass.
Okay,
and then you
great.
can go scroll through melamine, you've got silicone, and then your phenolic cotton cloth.
Okay. So this is really, really interesting. And I assume that maybe if we scroll down more, we'll see how this happens for other forms. Is that right?
That's
okay,
correct.
Perfect. So for instance, an EPGC 21 would be a tube form. And I know that because I wanted to set it above. Now, the thing that I find interesting, we can go back to the sheet grades, but on some of those, it looked like we have multiple grades that will certify to the same standard.
That's correct.
So why don't we pick one of those and click into that grade and see what we learn?
Okay, we'll do NP510A. So that
Okay.
takes you right to our information page on that grade, the Norplex-510A grade, which is an FR4. And here you'll see we list all the certifications for that grade. Like we were just showing IEC EPGC 202, we also certified to the ASTM FR4, the MIL-I 24768/27, NEMA FR4, and then some miscellaneous ones down here as well.
Now, Deanna, if I were to buy this and on my order, I said, hey, I need EPGC 202. Does that mean it's automatically also certified to MIL, or do I need to specify that at time of order?
You need to specify that at time of order. There is a lot of overlap between all these standards. However, there are some specific differences between all of them that we need to make sure we've got covered. So you need to specify at the time of order so we can make sure we've got it covered.
And the other thing I'd like to ask real quick is, I assume, just like you were talking about on IEC, that what we really need is the EPGC 202. I assume for MIL, if someone came in and said it's MIL-I 24768, you're going to need a slash and a number, correct?
Yep, right here, the /27. That slash and then a number really helps us dial in what exactly you want or what the requirements are.
Okay, so let's scroll down and look at this.
Sure.
What documents are here, and then maybe we could go take a look at the MIL page and see how that lays out as well.
Yep, we can do that. So if we scroll down, we've got technical data bulletin. You can see we've got two separate ones here for 510A. One more geared towards IEC. Like we were saying, that's an international standard, so we've got some units, and their testing is slightly different. And then we've got an NP510A, just a standard technical data bulletin. We've got your SDS here, and then we've got some other additional information, kind of comparing FR4, G10, G11. And then you can go down, we've got some cross-reference, some tolerance. So a lot of helpful information can be found on this page.
Great. So that's really cool. And I think that there's a lot of information that you guys have put together and made available to everyone. Can we go back maybe and take a look at that MIL page? So again, you're back under
electrical applications, industry standards.
You selected the MIL.
Correct.
And so if we scroll down here.
Yep.
Okay, so it's built very much like the IEC page. You have the grade type, a short description, and then links to the grades that would certify.
Correct.
Real quick on the MIL, I've been doing this for a little while, and I get confused by all the letters, the GEF and GEB. Are those super critical to you when we're specifying the material?
No. Not nearly as much as IEC. Really what we need is the slash and then the number, and we can take it from there. Got it.
That's really, really helpful. So, it's interesting when you were in the NP510A, one of the things that was there was a G10 versus FR4. So,
yes.
I've been around and I know those are NEMA designations, and a lot of times people ask me about G10. If I wanted to understand specifically about G10 versus FR4 or whatever, are there resources, and could we talk about that a little bit?
Yes. This is a very common question we get, and one that probably will deserve its own talk. But since we're getting to the end here, I can show you where you can find some of this information on our website. So we'll go here, just select that. And then you look, if we scroll down here, we've got this handy, what is G10? So let's go to learn more. So then in here, it's what is G10 glass epoxy? It's kind of going to give you a short answer, a long answer, a little bit more information here. Kind of scrolls through, you can read that. Talks about TG. But what I'd like to also point out too is, on the right side here, we've got some additional information. What is G10 versus FR4? This is a very common question we get. You can download that PDF and get some more information there. And then, of course, we've got another frequently asked question, which is is G10, is it not G10CR, or is it? And here's some information you can learn about the cryogenic applications for G10CR.
Really great. So, you know, I was reading over here on the left-hand side as we were going, and I think it's sort of in these last paragraphs is your point, right? You know, so this is under the structural side of the website, and a lot of structural designers are very worried about TG. They're worried about hot, wet conditions, things like this. And
Yes.
under the NEMA standards, there's no requirement for TG.
That's correct. That's correct.
So, you know, this is where we like to work with people and have a conversation about how these materials serve as great baselines, great starting points, but then how we can layer on additional requirements or make modifications to make them more suitable for their environment. So, you know, we started out here saying we're going to keep this to 15 minutes. We are now almost approaching 16 minutes. I'm going to offer again for anyone who is listening in, if you got any questions, go ahead and put those in. I really want to thank Deanna for taking her time. Clearly, she is our expert. You'll see her name at the bottom of our certifications. So she really knows this stuff well. And as we go to wrap up here, I'm going to share my screen one more time. And once again, want to thank everyone for joining us today. I want to encourage you to connect with us on social media, particularly LinkedIn. You can subscribe to our Bright Talk channel, where we'll continue to work to put out content like this. But here's listed Deanna's contact information. I'm getting a little flicker on the screen. I hope it's not coming through for you guys.
It is for me as well.
That's unfortunate. So everybody knows this is live. It is real. We'll try again. Second time's a charm. So there you go. Yeah, I'll keep. So Deanna's contact information is listed there. You can actually read it this time. Feel free to reach out to her about questions about these standards specifically. Of course, my name is Dustin Davis. I'm the Director of Business Development. My email is listed there, and I look forward to discussing with you needs for applications engineering or how these materials may be adapted to your specific use cases. So once again, we thank everyone for your time today and hope to see you next time. Thank you.
Thanks, guys.